ACE is, which is area control error, how we calculate it. Basically, ACE is, like if there is interconnection to the system, it will take it into, if there is tie line between two utilities, they will say, okay, what is the difference between the measured and the program into the programmed value of the flow between two utilities, and plus the what's called, this is K, which is something called a system sensitivity, and this is a factor multiplied by the delta in frequency difference between the measured frequency and the nominal frequency. So based on this, we will, like AGC will calculate ACE. So ACE is calculated here. It's automatically calculated by software every 4 seconds, because it will take the frequency measurements, and every 4 seconds they will calculate the frequency, and every 4 seconds they will do some calculation for the ACE, calculate the deficit in the system, and AGC will change this deficit into megawatt, and this megawatt, it will split it among the number of units contributing to AGC control. Okay. Here is sort of like, this is when there is, again, this is another illustration of the previous slides. If I have two control area, and this is where ACE, which is the difference between tie line flow between the programmed and the measured, and the two frequencies. And this is, AGC can even work with more than 2 areas, more than 1 area. It could be 3 areas, 4 areas. So it could be 4 utilities connecting to each other. For example, give you a typical example. If you now look at the Gulf states, you will find Emirates, Bahrain, Qatar, Oman, Saudi Arabia, Kuwait. All of them, they are connected. Their grid is connecting to each other. And they say that every every utility, every country want to join this something called GCCI, which is Gulf Cooperation Country Network. They have to have AGC. This means that AGC, it's control the flow in the tie line between various countries. So AGC is very important when we speak about the local utility itself control business, as well as the control of the tie line flow between various utilities. AGC normally, when it's like, it has sort of like certain control mode, something called constant frequency, which is CFR, which is mean that if I want to AGC to control only the generators of the area, of my local area. I'm not connected to any other external utilities. I'm totally isolated utilities. Then they will let AGC work under something called constant frequency, which is, it doesn't take any consideration for any flow in the tie line. And in this case, for this CFR, which is constant frequency, we calculate the ACE as only the difference between, which is the system sensitivity here, beta, times the difference in the frequency. And sometimes when there is interconnection, I work with something called constant net interchange. If I want to control the interchange, if you have, for example, between India and China, there is interconnected, there is tie line, and I want to control only the flow into that tie line. So only I take into account, which is the difference, which is CNI, the difference between the interchange and the actual interchange and the programmed interchange, and I will let AGC control this. And if I have the control, which is this is the most common, which is tie line bias control, which is control the flow into the tie line between different utilities, as well as take care into the local frequency of each utilities, to make sure that the frequency is 50 in all utilities. Because, you know, if you have too many utilities connected to each other, one of the main conditions that all utilities should have the same frequency. Otherwise, there will be imbalance in the system. So AGC normally calculates, will transfer this ACE value into set points, which is, it calculates each 5 to 10 seconds, and this set point sent to nominated generators. Okay, AGC required it's like AGC be able to function correctly and control the energy production in utilities, normally it has to have a measurement, which is some measurement has to come to the control center, which is coming to SCADA, which is system control and data acquisition. AGC is interfacing to this SCADA real-time system, so it needs measurement. It has to have sort of like a continuous, continuous flow of the active power from all the generators all the time, and whether generator is connected or not connected, and the control status, which is the generator is remote or local control. For example, if generator is set under local control, which the power stations, they say, no, we will control our generator by ourselves. In this case, AGC cannot control that generator, and operator, they have to use the telephone to call them and ask them, can you please go up, go down manually? And you know how this is going to be difficult. So AGC, it's required mainly these type of the measurements, as well as here additional signal for AGC control, which is need like each generator. Normally the generator, they are afraid. For example, if I have a generator, you know, the generator is very expensive equipment. We speak about multi-million of dollars. So if there is fault in generator or care, then there will be an issue. So when they design the generator, they say, okay, that generator is doing something between, say, 50 megawatt and 100 megawatt its capacity, minimum 50 and maximum 50. So they will let AGC to work within that values, something called LFC maximum and LFC minimum. So if a generator capacity is between 50 and 100, normally they said they let AGC control the generator while it's between, say, from 60 to 90, rather than go to the border. Sometimes there is an issue. So AGC try to be safe, and as well, what's needed for AGC as well to know is the frequency on the system all the time, and the frequency and the tie line flow. It's very, so these are the measurement needed for AGC operation, and normally they will come from the SCADA system, and this SCADA system is different word. We can speak on it on different different session. Okay, so if you look at this, this is sort of like the design of AGC and interfaces of AGC. So AGC here in the middle of the heart, it has its own database, which has all the generators data, all the power station data, all of it modeled here, and this data is being kept updated by the operator. And we have, this is the unit commitment. Sorry, it has a unit commitment. That unit commitment we'll talk about later on the tertiary control, which is the fourth level of control. So AGC is exchanging the data with unit commitment and economic dispatch, and on the left, AGC control the exchange measurement with SCADA, which is AGC unit control and telemeter data. When the telemeter data, we spoke about it in the previous slides, which is the megawatt output of generator, the status of generator, whether it's connected or not connected, the generator status, whether remote or local control, and the frequency, all this coming from SCADA. And as well, it will go to network database here, where is the rest of the other energy management system applications, like state estimators, load flow, contingency analysis is communicating. All the generation data is fed into the network data. And this is another, and this is for interchange schedule database. So AGC is sitting in the heart of all the EMS system, exchange data, and helping the operator to control the generation demand balance 24/7. Okay, this is sort of like if you say, for example, there is in a system, there is only 2 units are connected to AGC, and the rest is non-AGC. And this is how we like to put it in a simplified way. If there is in a system, there is 2 units connected to the system, and AGC, they need extra 25 megawatt. How this 25 megawatt is split between the two units connected to AGC system. AGC, they will take care into consideration something with participation factor, and one unit will take it maybe 18, the other unit will take 7. How this unit has decided AGC decided to give this unit 7 and the other unit 18, it's based on two issues. First is the efficiency of the unit, and the second is the ramp rate of the unit. So it will become the faster unit and the most efficient unit. And this is how can we allocate, if there's 3 units or 4 units or 100 units, it will all of the time will be based on efficiency as well as the speed of the unit. Okay, the set point, which is like AGC will transfer the required from each unit at the set point, which is a unit is doing 60, for example. It needs from this unit to produce another 7 megawatt. It will send a new set point to the unit, to generator, and it's going to send a new set point with 67, and this is without interference of the operator, and this is happening 24/7. And AGC could send 2 forms of command, either sometimes set point, which is the recent one, the modern one, and before it used to use something called pulse control, which is it's old but still in use in subsystem, but both the set point and the pulse are translated into megawatt requirement from the power station. So normally in the system, they don't put all AGC on, they don't put all the units under AGC. They put, say, sometimes 60%, 70% of the unit under AGC, the other, say, 30%, 40% under manual control. And this is for the security, because sometimes to keep things automated 100%, there is a risk of something occur. So normally they put some units under remote control of AGC, some unit under manual control, and this what's happened. And this example shows how they control the system by mixing of the manual and automatic control. So here there is comparison between the manual control and the automatic remote control. And for example, if you look at automatic at AGC, which is automatically unit are set for desired value based on exact unit model. Manually, it's set for desired value, and it is ad hoc. Automatically, unit is set for frequency regulation mode based on the exact unit model based on frequency, and manually, it all the time it's based on the experience of the operator, and sometimes he hit it right, sometimes he hit it wrong. So automatic would be more preferable and would be required most of the times. So within AGC, it's like, because AGC, they need to distribute, this is area control error among number of units. So it has to be based on economic factors, on efficiency. So it like AGC has something called economic dispatch, which is nested within AGC and automatically control the efficiency. They distribute how to distribute the deficit in an area automatically and keep the balance, which is something it's called economic dispatch. So AGC traditionally, if you go to any utilities, you will find there is an issue, and especially the power generator owner, he is concerned sometimes about the using of AGC. He will tell you, okay, guys, you are having my generator. My generator is far from your control center, 1,000 miles away, and you want to control my generator remotely. I don't trust you. This is no, I will not give you my control. And normally the TSO, they convince him this is better for you, and really it's better for him and more stable for his unit, and his unit will be will be operated on an efficient level. And sometimes he will say, what about if the generator tripped because of AGC? There is nothing like this. Normally, it's like AGC is tuned and never sort of like been cause of tripping a unit. And sometimes you say there is something maybe as well. The third one, which is need sort of like a little bit sort of like more session about the combined cycle. The combined cycle where we have the steam coming out of gas turbine, it will go again into steam turbine to be more efficient and produce more power. And this sometimes they said will be an issue with AGC, and as well like utilities normally address this and say and this is it's no issue. Sometimes they said AGC you will control the unit from minimum to maximum, and people say and the people who defend AGC, they will say, okay, no, we will let your AGC to work in regulation range. We agree with you. For example, when I told you if a unit is doing between 50 and 100, this is minimum maximum, we let AGC to work between 60 and say 90, and this is safe mode. AGC keep changing like instead of let the unit work on a steady state, one value all the time, AGC keep changing the unit, and this impact on the age of the machine. No, this is not sort of like an issue. This is not real, not correct. AGC, what will happen with AGC when there is emergencies in the system? AGC will sense when there is emergency in the system, and it will suspend its operation. And AGC as well can work with the market when there is energy market in any country. Okay, so we finish from the first one. We finish from the first one, which is the primary domain, the AGC, and we'll go to the tertiary, which is both unit commitment and economic dispatch. So if I go down to briefly, what is the economic dispatch and what is the scheduling? A scheduling, it's basically it's like the operational planning engineer in the control center. They have to put to plan the generation profile for the next 24 hours or 48 hours. So what they will do something. They will utilize some scheduling programs. And this is, if you look, most of utilities, not most, every utility, they have to use this scheduling program. Sometimes they call it unit commitment. And basically, unit commitment, it's assumed you have N available generation and units in the system, and the forecasted power for 24 hours or 48 hours ahead. And we say which subset of this unit should be used to satisfy this demand in order to obtain the minimum operating cost every hour. And this is unit commitment is work on hourly or half-hourly basis, and then it will be coupled with the list resolution, which the economic dispatch, which said that you have a number of unit generator or desalinator and already committed to connected to the system. And when there is a variation in the demand, much variation, like we need extra 100 megawatt, how much each unit should be changed to address this extra megawatt or less megawatt. And this is the economic dispatch. And this is the fourth cycle. Okay, we have sort of like what's feeding the scheduling and dispatch, which is we need load forecast, application, and the unit commitment and economic dispatch. So this is sort of like schematic diagram for the scheduling and dispatch process. If you look at the one from the left, which is all the input, production, bed availability, initial condition from SCADA, load forecast, production, all this is coming. Okay, all this is coming into the unit commitment and dispatch tertiary programs. And this is really like it is complicated programs based on optimization routines and like mixed integer, linear programming, dynamic programming, and all this sort of like fed, and the plan will be sent to the control room for their generation profile, so that the operator in the control room, they follow this profile. So these are four domains of the control, which is primary, secondary, tertiary, which is into two areas, which is the economic dispatch, and unit commitment. Now, where this can help you in your career, your future. So if you find this presentation really is good for you as a graduate engineer to go to any control center and say, okay, I know how you control your generation 24/7. I can help you in this, and where this fit, for example, in major vendors energy management system, like for example, ABB, Siemens, GE, Alstom, name it, whatever. And as well, you can work in any power generation plant control center where those people who are working in the power plants. There is too many power plants, for example, and it has to be served and maintained by tens or hundreds of engineers. So this is 4 way of control the generator. It will help you and work in this. And it can work in, it's like you can find an area with transmission utilities, TSO, in the control center, operational planning, dispatching, real time, network security, power quality, transmission design, and strategic planning. As well, you can work with the distribution utilities and suppliers. You can work with a regulator, energy regulator. You can work with the energy market where they are doing energy trading. You can work with energy consultant firm. You can work with smart grid infrastructure and firms. And again, the companies who are like, you can find, like you check all the LinkedIn, everywhere you'll find who are working there. So major utilities, generation, in every country you'll find generation, transmission, and distribution companies, local and worldwide. Major scale and energy management system, namely like Siemens, ABB, Alstom, Electric, OSI Open System. Major consultants like Mott MacDonald, BB, Parson, Kima, ESBI International, and as well research and development institutes like universities, and so on.